first pattern that we are going to discuss today is the strategy design pattern. You may ask why this particular pattern? Because this pattern forms the basis of all the other patterns that we are going to discuss going forward. Meaning, once we have understood the strategy design pattern, we can easily understand the other design patterns that we are going to discuss. Along the way, once during the course of our discussion, we will look at some of the object-oriented principles that we are going to apply or needs to be understood for correctly applying the strategy design pattern. So let us now discuss the strategy design pattern. As with all the other patterns, we will be taking a problem solution approach. So the problem here, or we're assuming that a customer has approached us and a customer has a problem that we need to solve. So in this case, what we need is the customer is coming to a development company and he wants us to create a game simulation application. And that depicts some ducks flying around or swimming around. So there are some specific requirements by the client. So what are the requirements? So the first requirement is at least 2 ducks species should be shown in the display. The duck should make some sound during display, and the ducks should be swimming in the pool. And the last requirement is the ducks should be displayed. So again, I'm reiterating, this is the first requirement that the customer has approached us with. So now we have understood what is the requirement from the client, and we are assuming that the company is ready with the developers. They are good with the object-oriented programming principles. So they have put up their sleeves and are ready to work. So let us see the first design they have come up with for this particular scenario. We are going to employ the good old object-oriented programming principles. So our base class is called duck. It will have 3 methods: a quack method, a swim method, as well as a display method. Once the base class is complete, we will create 2 subclasses, one called Malla duck and the second one called marble duck. Once we complete, we are going to execute these 2 classes in the main method just to see that everything is working perfectly fine. We have completed the application, we have executed, tested, and we have sent this prototype to the client. The client has seen our application and he is really happy with the whole setup. Now that he has seen the application running, he has some new requirements. So these are some of the new requirements that he wants us to put into the software. The first requirement the clients wants us to introduce is to introduce a new species to the midst, which he wants us to call as the rubber duck. If you remember, we have already 2 species of duck already introduced into the application. The second behavior he wants us to add is the flying behavior. That means he wants the ducks to fly around in the display. And the last behavior is, if you remember again, we had introduced a quack behavior, which is the sound behavior produced by these ducks. For this new requirement, he wants us to have each duck produce their own sound. So let us see how we are going to incorporate these changes in requirement. The first requirement is really easy. just create a rubber duck class. The next requirement that was asked was to create a flying behavior. So the designers thought how to incorporate that particular requirement. So they thought that because every duck needs to fly, let us put it into the base duck class. And now the last requirement, that every duck should have their own sound. So you can see here, our design consists of the quack behavior, which is the sound making behavior of these ducks. But here, because the quack method is in the base class, every other duck is going to make the same sound. So the designers decided that every duck should override the quack method and make their own sound. So what we did just now was to override the quack method from the base class. So if you look at the mallard duck, we overrode the quack method and then gave some specific sound to the mallard duck. We left alone the marbled duck so that we want to make the marbled duck wants to make the same sound that is the duck class is providing. And of course, we did the same thing with the rubber duck too. We overrode the quack method and made some different sound. So by this, we have completed our requirement of the client. Now we need to test the application before we send the prototype to the customer. So here we are creating the new rubber duck instance and executing the methods along with all the other methods to see whether the application is working fine or not. We have completed the application and we have sent the application, the prototype to the client. We have received a reply from the client. But this time, the client is not happy. What he was expecting was that the new species, the rubber duck that was introduced in the last requirement, he never wanted those ducks to fly. So maybe it was a mistake in understanding the requirement. But apart from this one trouble, he is also not liking the design of our application. So he is asking, we just started with 3 species. There can be hundreds of species that he needs to add going forward. So for each species, he may need to have some different flying behavior, or each species may have to produce some different sound. Likewise, he may be introducing some new behaviors as and when the requirement comes up. So, are you going to create classes and then override the methods as and when the requirement changes? For example, what we can see in this particular application is that the requirement just changed. That means, of course, what was the requirement? The client wants the quack behavior to have different behaviors for each of the ducks. So we overrode the quack method in the mallard duck as well as in the rubber duck. So now the requirement of the client is that the rubber duck need not fly or shouldn't fly. But as of this design, because the rubber duck is extending from the duck base class, the rubber duck or any other duck extending from the duck class will fly. But that is not the requirement of the client. The rubber duck shouldn't fly. So As a first instinct, what exactly should a programmer do to overcome this difficulty? The easiest thing that he can think about is to override the fly method. So here we are going to override the fly method and leave the fly method blank. So what happens here now? We are actually catering to the requirement of the client. The client says that the rubber duck shouldn't fly. So we have overridden the fly method and we are leaving the implementation blank. But then, is it a good design? We have just three species of duck. One is the mallard duck, second is the marbled duck, and the third is the rubber duck. Suppose there are hundreds of ducks like this, and each of these are going to show different fly behaviors or different quack behaviors. Are we going to each of these ducks override the method and leave something blank and give some implementation based on the requirement? That is not a good design. We call these kind of designs as a maintenance nightmare. So we know that the design of the application is not catering to a change in requirements. So we know through experience that how much well defined or well designed an application is. That application should be able to make changes based on the requirements. And we always say in software development, the one constant that is always there in software development is change. So our endeavor always when we design an application is to how to cope the design with changes. So what are the minimal design considerations that we should have when designing an application? So the first design principle that we should keep in mind when we start to design an application is to identify the aspects of the application that vary and separate them from what stays the same. So keeping that design principle in mind, let us try to identify what are the aspects or behaviors of the application that changes with the new requirement. So if you look at this particular duck class or in this particular similar application, we can see that the quack behavior or the sound making behavior, the client wants each duck to have different behaviors. And not only that, the client also wants each duck to have separate fly behaviors too. So based on the design principle, these are the two behaviors that we need to understand or we need to identify and separate it. So just now we applied the design principle. That means identify those aspects of the application that is changing. But that particular design principle does not end there. The second part of that design principle tells that, of course, we have already identified those aspects that varies. What we should do with that particular aspect that we have identified. So take what varies and encapsulate it so that it won't affect the rest of the code. So I'm reiterating this design principle. The actual principle is just to identify the aspects that change very often. But what to do with that aspect, that behavior that we have identified that is changing so often, we need to encapsulate it. So that's the second part of it. So let us do the design principle that we just learned in practice. So what we are going to do, two behaviors we have identified. One is the quack behavior and the second thing is the fly behavior. What we should do, we should encapsulate it. What do you mean by encapsulation? Of course, that is the object-oriented programming principle. That means this particular duck class should have these behaviors encapsulated, like private, whatever is the behavior. So fly is the behavior. So assuming that we have something called flyable, some class. Then, of course, that is how we are going to encapsulate it. And of course, then what we are going to do, we don't need this fly behavior anymore. We will delete it let us delete it now itself. So what we have effectively done, we have removed the fly method that was part of the duck behavior, because why? We already know that that is one behavior that often changes with different ducks getting introduced. So because of that, we have identified that particular behavior as an aspect that often changes. So now then, once we have identified that, the second thing that we are going to do, we need to encapsulate it. So we have encapsulated that particular behavior. So what we need to do, of course, there is no flyable class or anything of that sort in this particular code. That's why the compiler is showing an error. So let us create a flyable. So what we are going to do, we are going to create, but instead of a class, we are going to create it as an interface. So you can see here, I have created an interface called flyable. And then I will specify what exactly is the behavior of the flyable interface, the fly method. You are with me? So what we have done, I'm reiterating again, we have identified that one of the aspects that often changes with change in the ducks is the flyable. So that's the behavior that we have identified, and then we want to encapsulate that particular behavior, and we have encapsulated that particular flyable behavior in the duck class. So we have effectively removed the fly behavior and introduced the flyable interface. Likewise, let us have this particular quack behavior also do the same thing. So what we are going to do, we are going to have a quackable as a behavior. So we are encapsulating. So because why? We are not going to have this particular behavior in the base class anymore. We will delete it. And then what we are going to do, we are going to separate that behavior into a separate class, in this case an interface. Again, quackable. So let us create this particular quackable interface too into the same package, and because it is going to be an interface, let us key, and then of course what exactly is the behavior. Quack is the behavior that should have that we should have in this particular interface. So we have effectively done, or we have programmed the theory that we just learned. That means whatever are the behaviors that often changes, identify those, and then encapsulate it. So this is what we have done. We have identified two behaviors that often changes, and then we have encapsulated it. We are not complete with our design. The next thing that we have to do here is to create a constructor. So let us create the constructor and use all these, the quackable and the flyable interfaces, like so. We are not complete with the coding. As you can see, there are some compilation errors and all. So let us complete the code, and then we will discuss what are the new code that we have introduced. So now let us look at the change in code that we have just made. If you look at the duck class, the only change that we have performed is I just introduced two methods. One is the perform fly method, and the second is the perform quack method. As you know, of course, when somebody creates an instance of the duck class, they will be creating an instance of an implementation of the flyable and the quackable interfaces. So, so that means that bird, if that bird needs to fly, they will use that particular flyable variable, instance variable, and then call the perform fly method. That's the case with the perform quack too. So to perform that particular sound making behavior or to perform the flying behavior, we have created these two methods. So you can see all the errors are now gone, at least for the time being. And the next thing that we have done is that, of course, we have gone into each of the duck species and we have created a constructor that takes both the flyable as well as the quackable behavior. And of course, we are calling the super constructor because by this design, we are telling that, or we are allowing only the mallard duck to be created by calling this particular constructor because there are no default constructors. So the programmers will be forced to pass the flyable and the quackable implementations, which in turn will call the super duck class and then perform the flyable and the quackable there. The same thing goes with the mallard duck 2 as well as for the rubber duck 2. So you can see here all the errors are gone. And the last thing that we have done here is main class where I have removed all the constructors or creating the instances. I have deleted all those code. And of course, because now if we are going to create the classes, for example, if I am going to create a mallard duck, I will be using new mallard duck mallard duck like so. I think mallard mallard duck like so. But now there is no default constructor. I have to pass in both the flyable. So you can see here the compiler is telling that we are expecting two arguments. So what are the two arguments? The flyable as well as the quackable implementations of these interfaces. So now let us complete the implementations of these flyable and quackable. So now let us complete the coding aspect of it. So you can see here that we will take the fly behavior as of now. If you remember, one of the requirements that came from the client was that some ducks will fly, some ducks shouldn't fly. For example, the mallard duck as well as the marble ducks, they can fly, but the rubber duck shouldn't fly. So there has to be two behaviors here. So for this particular interface, we are going to have two implementations of these interfaces. So let me just create a separate package. Again, I'm not giving specific to different package naming conventions and all for the time being, which will unnecessarily make the video lengthy. It's already lengthy enough. So what we are going to do, we are going to have an implementation of this particular flyable interface. So we have two behaviors. The mallard duck and the marbled ducks, they can fly, but the rubber duck shouldn't fly. So we are going to have two flyable implementations. One of the class, maybe we will give fly with wings. And this is going to implement the flyable interface. Yep. And then let us implement the fly method. So let us give flying with wings, something like that. So this is one of the implementations of the flyable interface. So what exactly? When we create a mallard duck, we are going to create an instance of the fly with wings. Why? Because those birds can fly. And but for the rubber duck, we need to have one more implementation of the flyable. We will give fly away, which is also implementing the fly, not a functional interface, implements the flyable interface. Let us implement the fly. So here we will see fly, no way, something like that. So likewise, so we have just given two implementations of the flyable interface. One is the fly no way. That means we will provide the fly no way implementation of the flyable interface for those birds, for those species of ducks that doesn't fly, and the fly with wings will be given to those ducks that will fly. The same thing will go for the quackable interface too. So let us give two implementations. One, I will give the quack, which is going to be a class which implements the quackable. And again, we are going to implement the quack method, and then we will give quack quack. And of course, we can give another sound making behavior for the rubber duck. So let us give one more implementation. Maybe this time, let us give another name called tweak, something like that, which also implements the quackable interface. And then we will give tweak. And that's it. So we have effectively given two implementations, two implementations for each of the flyable as well as the quackable interfaces. Last thing that we need to do, let us go to the main class. So for the mallard duck, what we are going to do, so the mallard duck is expecting the flyable and the quackable. So let us give, because the mallard duck will fly, let us give new fly with wings as the implementation, because the mallard duck will fly. And then let us give the quack method, because it is going to use the quack. And not only that, we will be giving the perform mallard duck. Oh, sorry, because we don't have any implementation. So let us give an a mallard duck like so. And of course, another design principle is that whenever we are going to create instances, always program to an interface, not an implementation. Again, that is discussion for another day. But for the time being, let us use the mallard duck and perform quack, and instead of fly, it is perform fly. You're getting what I'm telling? So I will leave the marbled duck alone because that has the same behavior. So let us create the rubber duck, new rubber duck, and here the rubber duck shouldn't fly. So we will give fly no way, and then new squeak method. SQ you squeak is the implementation. And of course, here also is going to perform, and likewise, let us create an instance variable of the rubber duck, which should be of type duck. And then, of course, we will perform the quack as well as perform the fly method. So what we just did here is that we just created an instance of the mallard duck by passing in the appropriate behavior on the fly. That means during the creation of the mallard duck instance itself, we are giving them dynamic behavior. So you can see the mallard duck has been given the fly with wings behavior, and the sound making capability is the quackable. For the rubber duck, because the client wants the rubber duck not to fly and to make a squeaking sound, we have dynamically specified those behaviors at runtime or during the creation of the instance itself. Let us see whether it is working fine. So let us right click and run the application and see whether it is working fine or not. So you can see here that of course, first it is the mallard duck. It is making the quack quack sound. And of course, you can see it is flying with wings. And in the case of a rubber duck, of course, it is making a different sound altogether. And of course, because it cannot fly, it's not flying. So the crux of the whole strategy design pattern is about how we can identify the different behaviors that change over time. So now what exactly Even if there are hundreds or thousands of ducks we are going to create, and if they have different behaviors, and if tomorrow the client is coming back and telling I have a new sound making behavior, or a new behavior, a fly behavior, or maybe a new complete new behavior altogether, the only thing that we do is to identify the behavior, create an interface that represents that particular behavior, and then give different implementations of that particular behavior. This is what is the strategy pattern. Let us conclude our discussion on the strategy pattern. We started our design by using good old object-oriented programming principles. Like we just created some duck class, and whatever the behaviors of that duck class was, we put those as methods. And then whenever there was some child classes to be created, we just created the child class extended from the base class, so that the child class gets the behavior of the parent class. And then whenever the requirement came of a different behavior, we overrode that particular behavior or the particular method in the child class. Again, this is simple, plain object-oriented programming. But then we saw that when there is a change in requirement, and when this change in requirement comes so often, those kind of a design or inheritance is not a solution in these circumstances. So when our application, when we design the application, when we need our application to cope with change in requirements, it is always better to have an is-a relationship rather than a has-a relationship. Or, to say in other words, has a is always better than an is a relationship. Or, in another way, if you look at the design principle, it says favor composition over inheritance. So that is the principle that we just applied. Instead of inheriting the behavior from the parent class, let us encapsulate those behaviors as a properties of a class. That's what this particular design pattern was all about. So the actual definition, if somebody is asking us what can be a one-line definition of the strategy design pattern, we can give it like this. The strategy design pattern defines a family of algorithms, encapsulate each one, and makes them interchangeable. So that's the maybe one line definition of the strategy design pattern. That means it defines a family of algorithms. Means in our case, if you look at just the flyable behavior, it has two different algorithms: fly with wings and fly no way. Or it can have a lot of algorithms. And what we just did, that particular behavior, we encapsulated it, and then we can interchange the behavior. This is the crux of the strategy design pattern. Hope you enjoyed learning this pattern along with me. Why this particular pattern is so important, as I told you, this forms the crux or the basis or the foundation of all the other design patterns going forward. So, thank you for listening.